Chapter 6, Section 3, Domain and Range, Master Video. Keep in mind you're probably not going to become a master of domain and range just by doing a few examples. So let's do some more. So domain and range, here we have a relation. This is a non-linear relation because clearly from the graph that line is not straight. Okay, so it's asking us for domain in number line notation. So let's do that. So domain is specific to x values only. So I just care horizontally what's going on. So it goes as far left as -6. But notice how this is a white circle, a white dot. So that is not included. Well, how far to the right does it go? Well, it actually goes on forever, okay, because of that arrow. So there we go. All right. So that's pretty much what our number line notation looks like. So -6, this is an open interval, and it goes to the right forever. It doesn't matter how long you make this arrow. Okay. Now, you can move on below to the range, but I'm actually going to do the domain of the next one, only because that's what I have visible in this slide. So we have a relation, but it's discrete, okay, because these dots are not connected. So how do you describe domain and range when you just have a bunch of points? It's actually pretty easy. All right, so what is the domain? Well, it's all of the values of x that we're allowed to use. Okay, well, this one dot, right, is there. This one dot is here. There you go. We have a dot already there. So I'm actually kind of doing the work for the number line notation already. There we go. Okay. So we actually just have a collection of specific x values, and because these are not connected, we're not allowed to use any of the x values in between here. So on a number line, you just place the dots. So this is -7, I believe. So I'll label that. And we have -4. That's nice. It's already labeled. Sometimes this thing doesn't want to write. All right. Then we have -1, which is right here. I'll label that. And we have 3. Why did I have to pick all these odd numbers? That's 3. And then finally here we have 8. So I don't have to label that one. There we go. They're not connected. It's discrete. There's your domain. Okay, so let's finish off the domains using different notations for the two relations. So going back to the first relation, we've already done the domain using number line notation, so we just want to use set notation. Okay, so the domain is the set, or the collection of all x values such that, well, such that what? Well, from the number line, all the x values have to be strictly larger than -6. So -6 is as far to the left as we can go. It cannot include -6. So I do not put a little line underneath here. So these are the x values. All right, now there is no right bound. Okay, the graph clearly goes on forever to the right, so I don't put anything here. It's continuous, so any real number. All right, interval notation. We have a left bound. It's not included, so therefore it's round. We have no right bound, so I get to use infinity. Whenever we use infinity, that is always rounded. Okay, so that concludes domain for the first relation. So let's do domain for the second, which is pretty easy. We only have specific points. So in this case, only specific x values that we're allowed to use. I've already plotted them on the number line. So as a set, well, the only numbers that can exist in this set are, what were they? From left to right, -7, -4, -1, 3, and 8. Okay, those are the only numbers in the set. Interval notation. Well, that's pretty easy. It's not applicable. We can't use interval notation because this is a discrete relation. There are no intervals. There are only specific numbers that we can use. So interval notation is not applicable in this situation. All right, let's determine the ranges of both of these relations. So again, I apologize I can't do any drawing on the graph, but you're welcome to do it as I did before. So with range, again, we're only concerned about what is going on with y. We're just describing what y values can be obtained. So that means up and down is vertical only. So look at the first relation. Again, that was the nonlinear one. How far down does it go? Okay, well, it bottoms out at y equals -3. But we shouldn't include that point because the dot is open. It's an open interval, so I'll make that open. That's a -3. So that's our bottom bound. But there's no upper bound. Okay, the graph can go up and up and up forever. So on my number line, I indicate that with an arrow to the right. The y can always be bigger. Okay, so let's translate this now into set notation. So the range of this relation is the set or the collection of all y values such that I'm always larger than -3. Or I could also say -3 is always smaller. Okay. Again, the -3 is not included, so I should not put a line under here. There is no right bound, so I don't need to put a number here. Okay. The relation is continuous. It's not discrete, so the types of numbers are real. Okay. So all numbers such that y is greater than -3, so you could also write it like this. Either is fine. Okay. But notice in this case, the inequality is opening up to the y. Okay. That means that the number -3 is always less. All right. How do we say this in interval notation? Well, we have a left bound. It is open. So that's a rounded bracket. That's where the -3 goes, comma. And what's the right bound? Again, there isn't one. It goes all the way up to positive infinity. Just remember, infinity is not a number. Okay? But whenever we use the symbol for infinity, in this case, the bracket is always round. Okay, so let's finish off range for the discrete relation we had up above it. So it's actually done pretty much the same way as domain, only we're going to be listing the y values. So the only y values that we can list are -2, 0, 3. It's in here, so I better label that as 3. And 5. Come on. There you go. And 8. So there we go. Okay, so those are all the numbers in my range. Set notation, basically I'm just copying these out. So these are the only numbers that exist in the range. 2, 0, 3, 5, 8. Those are the only numbers that exist in my collection. So there's no need to say real numbers or give any inequality bound or any description like that. Okay. It wouldn't be wrong to put y in the beginning with the such that, but I didn't bother. And once again, interval notation. In this case, it's not applicable because there's really no interval. So there we go.